share the screen. This paper, all the UPSC ones, I think I discussed, right? The last few pages. All the IUPAC nomenclature of those compounds I discussed, and I'll discuss the remaining MCQs. There are nearly 40 MCQs from the past MCQs. Plus, organic also we had to start alcohol, aldehyde ketone. I think benzene I compared aliphatic hydrocarbons and benzene isomerism. Then IUPAC nomenclature of organic compounds isomerism, and then organic chemistry, the most important things, like other than the organic reactions and conversions, the rest we have done. Alkanes we have done reactions and mechanism and free radical, like all these reactions. And alkene also we have done, alkynes we have done. Then benzene benzene also we have discussed. The theory also I have given you, and the questions also I have done, but we have to do more questions. Before we discuss the essay type questions organic chemistry, we have to complete the all the lessons. We have to complete organic chemistry, otherwise because you won't get essay type questions only from one lesson, right? So unit 7, 8, 9, 10, there are 4 lessons in organic chemistry, and we have to benzene also I have discussed in detail, and I discussed some few conversions from based on benzene reactions, base conversions. And then we had to start alcohol, aldehyde and ketone, the next one. Have I given any theory related to aldehyde, ketone and this one? No, right? No, right? Yeah, okay. And today I think Vinhara, she informed me she won't be joining today. She has requested recording. So all the others are there, right? Now, have we done this? Shall I discuss these MCQs, or shall I go for the organic? If we have done this paper, I think this one you have time to Leon I posted the essay direction of this paper. So I will discuss this next week. You have enough time to do it. D block essay type questions. So I will discuss D block MCQs. Today shall we discuss this? Please raise a hand. How many of you have done this? These MCQs, remaining MCQs? Tamasha? Okay, then we will discuss these MCQs. Yeah, I think only IUPAC ones I discuss here, right? Yeah. Okay. All right. So 2001 question number 57, because old syllabus there were in MCQ paper there were 60 MCQs. 60 MCQs. Now only they have reduced into 50. Right. You can pause the so this is statement questions, no? The last 10 MCQs you are getting the statement questions in your paper. So this is based on the statement questions, and you can post the answer to the chat if you have done it quickly. And do you have questions related to this? Are you okay? Do you want me to discuss more questions from the IUPAC part? The inorganic and organic both nomenclature part I have done with you now, and all the past MCQs also I have done. Do you have any doubts related to that, or do you want me to discuss more examples? If you have, tell me, then I'll discuss few more questions. So I think last week we discussed a lot of questions, right? And I gave the theory also, the short notes. Right, okay, so question number 1, all of you gave the same answer. The fifth answer is 5, both are false. Aqueous solutions common debug elements are always colored. That's wrong. Yeah, that's wrong. And ions formed by a d block element always have a partially filled d orbital. That is also wrong. So there are examples for that. I don't need to explain that in detail. You can give one example. So zinc complexes are not colored. Complexes formed by, if you only write near the first statement, write the reason. Actually not the answer, the reason also you should know. If you are fully okay with that, no need write. Otherwise write example, the complexes formed by D block 3D series of the zinc. Zinc is not a transition, so that is not colored zinc complexes, and always having a partially filled, that also wrong because of zinc. Right. Then and the other one is copper, right? Please write there are two ions. I will look at the screen. I will annote on the screen. There are two ions, zinc and copper Cu plus. Copper Cu plus and zinc are the evidences for this. Complexes formed by Zn2 plus and zinc. They are not colored. So remember, the colored complexes are formed when d orbital is when d orbitals are incompletely filled. Please put a right. Complexes become colored. Actually, not the answer, because the answer you can get from the marking scheme also. So actually, I want you to learn something new from each MCQ, right? So therefore, additional information you better copy down in your short notebook. Complexes become colored. When d subshell is partially filled. When d orbitals are partially filled. When d orbitals are partially filled. Partially filled. Right. Then when d or else opposite of this, right? When d orbitals are completely filled, those cationic complexes are not colored. When d orbitals are completely filled, cationic complexes are not colored. So the second one also the evidence. This one also you can write here what? Zn2 plus and Cu plus. So they are no partially filled d orbitals of these ones. So the ions, they are ions. So zinc Zn2 plus and zinc 3d10 Cu plus also like that, right? Then question number 2. Okay, very good. With this understanding, if you have done it, very good, right? Then question number 2, I'll erase the screen. Second question, can you post the answer to the chat? Second MCQ. True, false. Okay, Pramati gave the answer. Tamasha gave Ishara. Right. True, false. So Pramati gave true, false, and Tamasha and Ishara gave true, true, and explain. First answer. 1 and okay. Let's see. Question number 2. MgCl2 gives precipitate magnesium. MgR is excess ammonium hydroxide, but NiCl2 does not give a permanent precipitate nickel hydroxide with excess NaOH. Okay. This is 2001. The next question number 58. Okay, I'll use the white the screen to explain this. Remember, don't just wait. Even though your answer is correct, if you want, you can. I mean, it's up to you to decide. You should better copy down if anything new, or to refresh your previous memory, the theory. Also, you can recall from this. I'll use the white background for this for the explanation. Let's see. Look at the screen. This is the difference. With excess ammonium hydroxide or with excess aqueous ammonia, precipitates are formed which cannot form complexes. Right? With you can put it right. With ammonium hydroxide or with excess ammonia, NH4OH, or sometimes they can give in the exam NH3 aqueous. So NH3 aqueous or NH4OH with excess ammonia. precipitates are formed by the cations which cannot form complexes. I put PPT. Precipitates are formed by the cations, but not all the cations, by the cations which cannot form complexes. Example, magnesium cannot form complex with excess ammonia, therefore it's a precipitate which cannot form complexes. Understood? That is number one. So if you put sodium hydroxide, I'll put this way, Mg twice. If you put sodium hydroxide, it form a precipitate magnesium hydroxide. Magnesium hydroxide, it's a precipitate. And to nickel ion also, if you put sodium hydroxide Na2, that also form a precipitate, but it will be a colored one. That's the only difference. From that also you can distinguish this. Nickel hydroxide also precipitate, NaOH twice. And if you add excess sodium hydroxide to this, excess sodium hydroxide into this, no reaction, no reaction. And it's not dissolving, no change. This also, if you add to nickel hydroxide NaOH twice, nickel hydroxide also, if you put excess NaOH, no change. Excess NaOH, no change. But if you take excess ammonia into this, I'll put a different color to this one, this hydroxide. If you put excess ammonia, NH4OH, then what happened? It will not dissolve because magnesium hydroxide cannot form, or magnesium ion cannot form complex with ammonia. That's the reason, right? So I put excess NH4OH, that is magnesium, no change, same as that. Either excess ammonium hydroxide or excess ammonium hydroxide, no change. But the other one, nickel hydroxide, if you put excess ammonia, then you will get complex. You get hexamine nickel 2+. So it dissolves. Precipitate dissolves. So you can copy down this. This is the theory behind this. Magnesium ion and nickel. Not only sodium hydroxide. If you want, you can put here, or ammonium hydroxide also you can put here, no problem. Either sodium hydroxide or ammonium hydroxide. Both will form the precipitate. Both form the precipitate. And both are insoluble in water. Both are precipitate means both are insoluble in water. But nickel hydroxide form a complex and soluble, magnesium hydroxide won't. So, but this is not a hard one, but they can again rotate this. Who can tell me a cation, metal ion, which dissolves, metal hydroxide which dissolves in both sodium hydroxide and excess ammonia? Who can tell me? A metal ion, metal hydroxide which dissolves in both. Yes, can you post to the chat, or like, can you unmute and tell? Lithium hydroxide dissolves? No, Ishara, lithium hydroxide is not a precipitate. I am asking metal hydroxide, that means a precipitate which dissolves in both ammonia and sodium hydroxide. If you add excess sodium hydroxide also it dissolves. If you add excess ammonia also it dissolves. What is the metal ion? There are few metal ions, so at least one. Can you guess? This one is easy, so that's how you can get the question. So does that? Yeah, anyone can guess? Very good, Pramodi. Aluminium hydroxide. Correct. Aluminium hydroxide. Aluminium hydroxide, okay, because it's amphoteric. Amphoteric hydroxides can dissolve in both ammonia as well as sodium hydroxide. What are the other, like from D block? Can you tell me a metal and a metal hydroxide D block dissolves in both NaOH and ammonium hydroxide? Not vanadium, Shara. No, manganese hydroxide won't dissolve in excess of NaOH. No, not copper. Copper hydroxide not dissolved in excess sodium hydroxide. I'm asking which dissolves in both ammonia as well as in NaOH. Excess. In excess NaOH also it dissolves, in excess ammonia also it dissolves. What is the metal? Zinc hydroxide. Right. Zn2 plus. Answer is Zn2 plus. If you take zinc hydroxide, it dissolves in both sodium, because zinc hydroxide is amphoteric. Zinc hydroxide, aluminium hydroxide, they are amphoteric. Even chromium CrOH thrice also possible. So this dissolves in both ammonia as well as in excess NaOH. Excess NaOH also it dissolves. Excess ammonia also it dissolves. That's because of the amphoteric nature. Is that clear? Both are precipitated, both dissolves. Therefore, it's very important to understand this. And cationic group analysis also you have to remember. Some metal hydroxide dissolves when the OH minus ion concentration is higher. Some metal hydroxide dissolves. What are the, can you remember the three metal hydroxide dissolves because with less OH minus ion, because you can suppress the releasing of OH minus from ammonium hydroxide by using an ionization suppressor, like which can suppress that ionization. I think D block short notes I have given that. Please refer that also. There is the other section where you can get questions. Let me show. D block short notes. Okay, again I'll show the screen now. This also I want you to go through. Here, can you see I have given you the D block. Please refer the D block. You don't need to copy down everything here. Can you see the screen now? Which dissolves in both ammonia as well as sodium hydroxide. Excess ammonia, these three. I am not given here. You can add sodium hydroxide also here separately. Hydroxides. Here dilute this is please refer page number 3 in your D block short note. Can you see here? Zinc hydroxide dissolves in excess sodium hydroxide as well as excess ammonia, and this one dissolves in lead hydroxide, aluminum hydroxide only with excess NaOH, and this one tin hydroxide. That is because of the amphoteric nature. So right here, due to amphoteric nature. D block short note, page number 3, due to amphoteric nature. Otherwise take time to copy down separately everything. In previous one there's a small correction. I put with excess NaOH also aluminum hydroxide dissolve, but that one there's a limitation here. And next thing, please refer with this. This same short note book, you have page number, this one. Can you see here? these three hydroxide, iron hydroxide, aluminum hydroxide and chromium hydroxide. These three hydroxide, you have to put ammonium chloride and ammonium hydroxide both, then the other metal ions will not precipitate, because if you put only ammonium hydroxide, all the metal hydroxide like those who are going to precipitate will precipitate. But if you put ammonium chloride, so this is the reason here, if you only can write that ammonium hydroxide partially ionized into NH4 plus and OH minus. It's a reversible reaction, NH4 plus and OH minus. And ammonium chloride completely ionized into NH4 plus and Cl minus. Now what happens, this ammonium ion released by the ammonium chloride will shift this equilibrium, I'll put an arrow, towards the left side. That means reaction is more favorable towards the reactant than the products. In the presence of ammonium ion in the medium, this is called common ion effect. Common ion effect. So here ammonium ion become the common ion. It will be released from both ammonium chloride as well as from ammonium hydroxide. Right, this is called common ion effect. So in the presence of ammonium ion, that means OH minus will be here less OH minus will produce because of the influence of ammonium ion come from ammonium chloride. So this is a second, don't forget the second reaction is reversible, because ammonium hydroxide is a weak base. Ammonium hydroxide is a weak, is very important, this part. You can put a star also here. So what are the three hydroxides which precipitate in the presence of low OH minus ion concentration? So you can write these are the three hydroxides which precipitate in the presence of low OH minus ion concentration. Precipitate in the presence of low OH minus ion concentration. Magnesium hydroxide will not precipitate here. Magnesium ion, to precipitate, it requires more OH minus. Understood? So, or else I'll give one example. Now imagine magnesium hydroxide, you have learned that is a precipitate. Now imagine you have a solution containing magnesium ion, and you can, this is how you can get the question here. Magnesium ion and aluminum ion, Al3 plus. Now both are precipitate. Now you add, if you add NaOH, you can't distinguish these two. Why? Both will form the precipitate. Right? Both will form the precipitate. If you add ammonium ion, ammonium chloride and ammonium hydroxide, this mixture, so this will generate less OH minus. Then who will precipitate? Only aluminum hydroxide. Magnesium hydroxide will not precipitate. So this is called selective precipitation. Selectively you can precipitate them. Is that clear? Otherwise magnesium, or if you put sodium hydroxide, both will precipitate. Therefore from precipitate to precipitate, or the metal hydroxide to metal hydroxide, the amount of OH minus ion required will be different. Now sometimes you might ask this question, so aluminum hydroxide read OH minus 3 times than magnesium ion. No, not that the ratio I am talking about here. There's something called KSP, or solubility product. You will learn this is linked with KSP in equilibrium lesson unit 12. If you can link that here, please refer unit 12 KSP lesson. KSP solubility product, SP for solubility, K for constant, solubility product in unit 12 grade 13 unit 12 equilibrium lesson. We will be discussing this in detail. So this is a combination of inorganic chemistry and physical chemistry. Is that clear? Right. So this is very important. So basically you should know the hydroxides which dissolves with only which precipitate only with NaOH, which precipitate metal hydroxides that dissolves with both NaOH and ammonium hydroxide, dissolves only with NaOH, dissolves only with ammonium hydroxide, and dissolves with both, dissolves only with NaOH, dissolves only with ammonium hydroxide. That's it. So not much, few. Dissolves metal hydroxide dissolves in excess ammonia. Most of the D block ones dissolve because of the formation of complexes. Most of the D block metal hydroxide, copper hydroxide, nickel hydroxide, right? Zinc hydroxide, they all form complexes with ammonia, therefore they dissolve with excess ammonia. With excess NaOH they don't dissolve. Why? Because only the amphoteric hydroxide dissolves with excess NaOH. And if you take zinc hydroxide, it's very important, it dissolves with both NaOH and ammonia, because with ammonia form complexes, with NaOH it dissolves because of the amphoteric nature. Is that clear? Zinc hydroxide is amphoteric hydroxide. Any questions? Any questions? So this is what I want you to refer, learn from this MCQ, hydroxide precipitation. So remember, please write in that question even if you want. Please refer the, what is this called, cationic group analysis. Have you all learned this in this, before? Please raise hand those who have learned this. Cationic group analysis, selective precipitation. Done. How many of you are this? Because you have supposed to learn this. Hydroxide. Okay. Right, good. Then let's move back to the previous question. Right. So then your answer is correct. Pramodi gave, the problem is now whether it's explained or not. Right? Both are correct. Now the next problem is whether it explained or not. So actually the first statement, second statement explain the first statement. Second statement will explain the first statement. Therefore, it's not a problem. Nickel ion form water soluble amine complex with excess ammonium hydroxide, but not manganese. That's the reason. That's why it's not dissolving, and the other one is dissolving. Okay, good. I think except who gave the correct answer for this question number 2. Tamasha correct. Pramodi, first statement also false. Okay, you understood this, right? Why the first statement is false? Why the first statement is, the first statement and second statement both are, Pramodi gave second statement false. No, yeah, second statement is correct. Magnesium cannot form complexes with ammonia, so that is very basic thing. Is that clear, Pramodi?
Yes, sir.
Right. Now, next one. Question number 3, you can quickly post the answer to the chat. Third MCQ. Yes. Which of the following developed elements likely to have the lowest melting point? That also I think I have given in a short notebook. Which one has the lowest melting point? Yes. This is 2003 question number 6. Right, I'll check the answers. Question number 3, all of you gave the fourth answer. Good. Manganese. Now who can tell me the reason why manganese is having the lowest melting point? Is there any reason for that? Any particular reason? Yes. Anyway, there's no specific pattern here. That is actually here the metallic bonding matters. This one there's no specific like variation. The lowest one is actually manganese. The most, all of you have got the correct answer. Tendency of the valence electrons to get delocalized. Remember the manganese, the melting point is 1244 degrees Celsius. Manganese, that's a metal. Second lowest one you get, what is the second lowest one? They're asking lowest to have No. Out of these manganese, yeah. Okay, wait. No, I'm asking now. Out of all the D block bonds, which one has the lowest melting point? In this one, the manganese is the answer. Okay. In this one, the manganese is the answer. If you take, I'll write the list: zinc, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and zinc. Out of all these, which one has the lowest melting point?
Zinc.
Yeah, zinc. Why? Yeah, good. Probably zinc has the lowest melting point. Why zinc has the lowest melting point out of all these? What would be the reason? Yes.
It's having a stable electronic configuration.
Yeah, actually, the metals, the melting point depends on ability of these valence electrons to get delocalized. Tendency of valence electrons to get delocalized is less. Zinc, it has completely filled outermost configuration D10 and 4s2. So tendency of valence electrons to get delocalized is less. Tendency of valence electrons to get delocalized is less. That tendency is less. Tendency of valence electrons to get delocalized is less. Therefore, what? The strength of the metallic bonding is less. So the strength of the metallic bonding depends on the tendency of the valence electrons to get delocalized. Tendency of the valence electrons to get delocalized depends on the ability of releasing them from the valence shell. Right? I mean, the strength of the metallic bonding depends on that. Second law. So therefore, please write here zinc has the lowest MP, that is around 420, right? 420 degrees Celsius. But anyway, no need to memorize the values. Melting point 420 degrees Celsius. Then next one. What is the second lowest melting point? Out of all these 10, lowest MP sinks. What is the second lowest? That also you should better remember. Lowest and the second lowest, at least you should remember. Second lowest is yes. Second lowest. Not manganese. One gave the answer. Yes, Pramodi, copper. Yes, copper. Second lowest, copper. That is 1083. 1083. 1083. After that, manganese. Third lowest, manganese. Third lowest, manganese. And you should know the highest value also. Highest one also you should mark. They can ask this some copying paper. So right here, highest and lowest you should know. First I'll mark the highest melting point, lowest melting point. Lowest, then copper will be the second lowest. Lowest, and this is the second lowest. And third lowest will be manganese. Third lowest will melting point manganese. So this one you get the value. I'll write the value here. Zinc around 420 and copper about 1083. Manganese around 1200. Then highest. Okay, I'll mark with a different color the highest melting point. Which one has? Okay, this one I'll write third lowest melting point. This is the third lowest melting point. Third, second lowest and third lowest. Lowest zinc, second lowest copper, third lowest manganese. Now remember, in the out of the metals given in this question, you can see they haven't given a copper and zinc. Copper and zinc is not given. If copper and zinc was given, you have to mark that one. So if zinc was there, that will be the answer. If zinc is not there, then copper. If copper also not there, manganese. That's why the answer come manganese. This is 2003 A level question number 6. So the answer will be manganese here out of the given answer. So the manganese has the lowest. Can you please mark the highest MP? Who can tell me the highest melting point? Which one, which metal can, which developed metal can contribute more to the electron, the sea of electron to make the metallic lattice? Which one can donate more electrons to the to form the metallic bonding from the valence shell? Yes. Tamasha vanadium. Vanadium. Okay. Somebody also give vanadium. 2000. Vanadium, what is the outermost configuration? 3D 3,4s2. 3D 3,4s2. Because remember the other thing is, if the electrons are unpaired, then there's a higher tendency to get delocalized than the paired electrons. Unpaired electrons having higher tendency to get delocalized than the paired electrons. That means tendency of delocalization is more from the unpaired electrons in the valence shell, not inner electrons, valence shell, valence electrons. So vanadium 1915, very good. Vanadium has the highest. What is the second highest? Chromium. Second highest, chromium. So very good. Vanadium has the highest value, and then chromium. So vanadium, I'll mark here highest, MP, and chromium second highest. So I wanted to remember the highest and lowest MP. There's no regular trends or the patterns here. There's no regular trends of the change of the melting point in the disk. There's no. But anyway, this type of questions I am not happy, because they are just checking the recall in the memory, like previous memory, or recalling the previous knowledge directly rather than analysis and evaluation. Then next one. Okay. Let's move on to the question number 4. I'll erase the screen. Question number 4. Which of the following statement is not true? Highlight the word not true. Can you quickly post the answer to chat? Regarding 3D transition elements, 2003 question number 8. How many of you are having these papers 2000 to 2005? Please raise the hand. From 2000, do you have these past papers? Okay, good. No. Because at least you should have 30 years. Okay, good. Okay, all of you have. Now at least you should have 30 years papers. For my advice, 1990 to 2020 at least. Then only it's 30 years papers. No? 30 years papers. So that means if you do after completing any lesson, if you do 30 years papers, MCQ essays and structured essays from that lesson, then no need to study anything else. Right? You will get all the patterns they could also. One of that they will rotate again, mostly. Right. So question number 4. I'll check your answers now. In the chat, question number 4. Ashan Ichara gave third answer. Pramod gave second answer. Third and second. First I'll check the second one. No two ions of these elements will have the same electronic configuration. No two ions can have the same configuration. Having the same configuration. That means 3D means the same list I gave you before. That means what? Scandium to zinc. Let's see. This is again 2003 A-level question number 8. I'll give one example. What is the single term that can be given for the same electronic configuration or same number of electrons? We call it, if same number of electrons, we call them isoelectronic. 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 If same number of electrons, if ions have in same number of electrons total, that is called isoelectronic, the word. But here not only the isoelectronic, the configuration also should match, will be same. So if possible, please try to, who gave the second answer? Pramodi, right? Pramodi, if possible, try to write the configuration of these two, then you will check, you can check yourself whether your answer is correct or wrong. I'll give two ions. First write cobalt CO3 plus and then Fe2 plus ion. These two, can you check the configuration? Please check. I think most probably you will get, these two you will get the same configuration. Cobalt CO3 plus and iron Fe2 plus. Yes? What is the outermost configuration here? You'll be getting the same thing, right? Pramodi?
Yes, sir.
Yes. So both this will get the isoelectronic and they will get the same configuration. Cobalt from 303 plus. Atomic number 27. This one atomic number 26. We'll get the same configuration. So this 4s2 is D7 and 4s2. So it's become after losing 3 electrons, it's become 3d6. 3d6. So this will become 3d6. 4s0. And iron having the configuration 3d6 4s2. So this Fe2 plus become, then it's becoming 3d6 4s2 4s0. So both these having the same configuration. Understood? Right. Okay. Now is that clear? Now answer can't be second then. Then what is the other answer you gave? Ishara and Tamasha gave third answer. Okay, let's see third answer. Compounds containing titanium Ti4 plus and Cu2 plus are white in color. Compounds containing actually they are asking not true, no? Actually this should be not true. It should be true. Which of the following statement is true regarding? Otherwise there will be so many answers, I think. They're asking not true. So this is not true, right? This is incorrect. The question they asked about incorrect one. Okay, I'll put the first one is correct. Highest positive oxidation state shown by manganese. That is correct. Why? What is the Mn7 plus? No, that is plus 7. That's correct. That you are okay is plus 7. That is correct. Second one is wrong. I proved now. So the Pramodi answer is correct. That is incorrect, right, Pramodi? Tamasha and Ishara gave compounds contain Ti4 plus and Cu2 plus white in color. Compounds contain Cu2 plus white in color. This is wait, there's a small correction here. Actually, then this is also wrong if you get Cu2 plus. I think original paper I'll check again. This should be not. Can you please make it Cu plus? Sorry about that. It should be Cu plus. In the original paper is Cu plus. Otherwise, both of you are correct. Can you please make it Cu plus? Cu plus, not C plus. Right, okay, now answer is question number, can you make, if you make Cu plus, then it's correct, right? Then it's correct, because copper complexes are not colored Cu plus, because Cu plus has no incomplete field D. Cu plus is 3d10. Cu plus is 3d10. Cu plus is 3d10 4s not. Therefore, no incompletely filled D subshell. Therefore, that's why it's not colored. The titanium titanium, one of the best example, TiO2. Most of the medicines, if you only can check most of the white medicines, it's white because of titanium dioxide. Even soap industry, most of the cosmetics to get the white color, they put titanium dioxide. Titanium dioxide production, that's a industry also. A level now you have this industry, titanium extraction and titanium dioxide production. Question number 4, answer is oxides of these elements having catalytic properties. Not oxide, actually, yeah, oxides as well as free one also having catalytic properties. So that one you can write, that's correct, no? Can you please write, can you write some oxides of these elements? Oxides as well as free metal, you can take both. V2O5, nickel, platinum. In organic chemistry, vanadium pentoxide is used, sulfuric acid industry. Example, right? Vanadium pentoxide is used in sulfuric acid industry as a catalyst. It's taught in oral chemistry also. V2O5 is used as a catalyst in sulfuric acid industry, and so in nickel, Ni, platinum used in catalytic hydrogenation organic chemistry. Oxides of these elements, so the oxides of V2O5, yes, therefore is correct. Next one, number 5. Some of these oxides of these elements are amphoteric. That's correct. Who can tell me amphoteric oxide here? What is an amphoteric oxide of D block? Look at the short notebook. D block short note. Here I have given amphoteric oxides under this. Here can you see Cr2O3 amphoteric, VO2 amphoteric, manganese MnO2 amphoteric. Okay? Please refer D block short note, page number 4. Amphoteric oxides. Amphoteric oxides. Right. Then next part. Shall I erase? Done. You copy down anything. If you want, you can copy down. So then you can guess the answer is right. Now Pramod, the answer is correct. I think the others are correct because of this printing mistake. Sorry about that. Otherwise, second and third both are wrong. But here answer I took second and I have done a change here. Original paper they have got Cu plus. Okay. Under the last one you can write amphoteric oxides. The same thing they can repeat again, right? D block. Amphoteric one you can write VO2, Cr2O3 and MnO2. Please write here MnO2 amphoteric, Cr2O3 amphoteric, and VO2 also amphoteric. VO2 amphoteric. Is that clear? Let's move on to the next question. Question number 5. Quickly post the answer to the chat. Zinc, cobalt and nickel, which is one statement applicable to all three, all underline, all word, all three elements, applicable to all three. Wait, there's a small correction. Energy loss. There's a small problem in this one. Wait. Uh, yeah, not relevant to the question given. No? Wait, I'll check with the original paper. Give me a second. 2003. Can you please check with the original paper? That's a small correction. 2003, question number 40. So this question you can skip because that's from the this question is wrong because it's not relevant with the actually the question is wrong here. So that's not from D block. That's not from D block. Therefore we'll skip.
Sir, you are muted.
Yeah, can you please copy down the 4 answers if possible? Actually this is the question is there. I'll change the 4 answers. If you only can quickly refer question number 41 in the paper. So this is 41 A level paper, question 2003, no? Yeah. Question number 41. So A, the answer will be they all are transition metals. Can you please change the answers? They all are transition metals. Second one, right? Second one, right? B. They are ions form complexes with aqueous ammonia. They are ions form complexes with aqueous ammonia. Then that is B. Then C, right? Their oxides are highly colored. Their oxides are highly colored. Their oxides are highly colored. And D, right? The most stable ion in the aqueous solution is the dye-positive ion. The most stable. Actually, I can ask you to refer this and do it, but I want to teach something from this question. That's why I'm trying to put the 4 answers again and discuss with you. Therefore, please change the 4 answers. The most stable ion in aqueous solution is ion in aqueous solution is dye-positive ion. Dye-positive. Now can you post the answer to the chat, everyone? Now I gave the 4 answers. Yes. Okay, so Pramodi gave B and D. Pramodi gave B and D. What about the others? Tamasha and Ishara? Fifth one? BC. Tamasha gave BC, correct? BD Pramodi, Ishara? Okay, let's see the first one. So anyone is Ishara, what is the answer? Which one will? Okay, sync is not a transition one. Right, okay, Ishara gave BC. Tamasha and Ishara gave the same. Ishara gave ABC. So you all have given three different answers. All three of you have accepted B is incorrectly. Right. The problem is C A and C A C D A C D. Now the Pramodi has accepted D also. Pramodi has given D also correct. All Ishara, why did you select A? All this transition. What the definition of transition metal or transition element? Zinc is not a transition one, no? Because in the elemental state or ionic state, it doesn't form an incomplete d orbital. No incomplete d orbital in the element state or even in the oxidized or the ionized form. So all are transition wrong because zinc is non-transition. Zinc is non-transition. Why zinc is non-transition? Because zinc ground state, no incompletely filled orbitals, as well as in ionized form or in ionic form also no d incompletely filled d subshells or d orbitals. B. Okay, so is that clear now? Zinc is non-transition. All three are non-transition. I didn't get Ishara. No, sir. A is not there. Okay. Maybe by mistake and you type this. So because in the okay, right. Okay, then no problem. Then B. Okay, let's see B. Who has accepted B? Also correct. All three of you have accepted B is correct. No, okay. Right, very good. B is correct. So that one I don't need to explain because all three form complexes with ammonia and that is common sense. So B is correct. C. Anyone has accepted C? Tamasha gave C correct. Let's see. Tamasha and Ishara both accepted C correct. The oxides are highly colored. Okay. Actually, C is incorrect. Why C is incorrect? Zinc, cobalt, and nickel, are the oxides colored? Their oxides are highly colored. Highly word also there. Remember, zinc oxide is white, not colored. Zinc oxide is not colored. Zinc oxide is not colored. Other two, cobalt and nickel form, but not the zinc. Zinc oxide is white. Then you might argue, sir, white also a color. Yeah, but true. But actually, here in chemistry, this if you take even magnesium oxide also colored white. So, but colored means white, no, except white. Like white is not considered as colored. Otherwise, any oxide is most of the S block and D block oxides also colored means other than white. Okay. Black also accepted, but not white. Is that clear now? Who gave C correct? Tamasha and Ishara clear. The oxides are highly colored. The oxide means all three. Not correct, no? Because zinc oxide is not colored. Why zinc oxide? Actually, again the same reason. Zinc oxide, zinc is non-transition. Zn2 plus. Okay. Then D. The most stable ion in aqueous solution is dye-positive ion. If you take the most stable ion, I have given at the beginning of the D block short notebook. Cobalt CO2 plus. Yeah, that's true, no? That's true. D is correct. D is correct. You can check even the short notebook. Zinc, the most stable ion is Zn2 plus. Cobalt, CO2 plus. And nickel also Ni2 plus. Most stable ion is this. Correct. Now what is the answer then? Pramodi correct. Answer is B and D. Very good, Pramodi. Ishara and Tamasha. Answer is B and D. Not you have got B correct, but Tamasha got C also correct, but that's wrong. And Ishara got B and C. C is wrong. Okay. Now remember, you can see now when you answer in these past four questions, you can see here. They don't ask only about one metal sometimes. They ask common to all the D block elements or the D block metals. So you can see they don't ask only about one element or one metal. Now here three elements: zinc, copper, cobalt, and nickel. Sometimes they ask melting point of everything. Therefore, but you learn in the school this separately, metal by metal. Okay, copper complexes, copper compounds separately, copper configuration, copper complexes separately. Nickel separate like that, manganese separate, but in the exam they make a soup. So it's integrated blended learning. Then let's move to question number 6. I'll erase this. Question number 6, 6th MCQ. What was the answer to the chat? 6th MCQ. Yes, maximum oxidation number +7. That's very easy. Everyone should get the same answer. Which one has the highest oxidation state, which is +7? Very good. Pramodi correct. Tamasha correct. Ishara also correct. Very good. That is manganese. The manganese, what is the highest oxidation state? +7. Right. Very good. What are the examples? Mn +7 is the highest oxidation state. What are the examples? +7. Mn O4 minus. Permanganate ion. KMnO4. MnO4 minus. If you take manganate MnO4 2 minus, then it's +6. No? Yeah. So MnO4. Question number 7. So good. All of you are correct this one. Next one. 7th MCQ. Which of the following statement is incorrect? Okay. This one, can you quickly post the answer to the chat? Right, 7th one, CD. Okay, all three of you gave the same answer. C and D incorrect. No, C and D incorrect. Let's see. 2006 question number 41. 41. First one, all transition elements are metals. That's correct. That's in the incorrect one. So all the transition ones are metal. Correct. All metal conduct metal. No, actually conduct electricity. Sorry about that. It should be conduct electricity. All metals conduct electricity. That's correct. Any metal, whether it's even mercury, conduct electricity. B and C. Answer you took C and D. Okay. B and C wrong. B and C correct. And the incorrect one, they are C and D. No, non-metal conduct electricity. That is wrong because of carbon. No? Because of carbon, that is C is incorrect. Because of example, right? Carbon conduct electricity. Carbon is a non-metal that which conduct electricity. Carbon also which form conduct electricity? Graphite. Carbon also which form conduct electricity? Graphite. Then next one, all metals are solid at room temperature. That is wrong because of Mercury, that's a very easy one, no? Because of mercury, right? So all of you are correct. Seventh one answer is CD. CD means AB correct 1, BC correct 2, CD correct means answer is 3. Yeah? If C and D will be the incorrect one, then the answer is 3. Question number 8. 8th MCQ. I think that's repeated, no? The previous one. Plus 7. Highest positive oxidation state. It's repeated again. No, this 2004. It's repeated in 2007. See this. Look at this. Now sometimes some of the A-level paper, some MCQs they can repeat. Like see, the same question they have repeated again. I thought by mistake and I have given. Now you can get the answer easily, right? 2007 first MCQ. That means 2004. After 3 years they have asked this again, the same MCQ. Both first MCQ. The first MCQ of the paper here. 2004 then to the 5 6 after 2 years they have asked the same one again, same question from the same area. What is the difference here? They have given positive oxidation, highest positive oxidation state. Same thing, this, they have changed the way they have asked the question, but the same theory, no? Ishara and Pramodi gave the answer. What about Tamasha? 8th MCQ? Tamasha 8th MCQ, what is the answer? Very easy. Answer is 5, right? Yeah, very good. Okay, 5. Okay, I'll mark the answer. Answer is 5. Then question number 9. 9th MCQ. Can you quickly pause the answer to the chat? Which of the following statement is not true regarding the transition word highlight? That is one of the active word here. Not true highlight. Not true highlight about transition. Yes, 2009 A-level question number 9. Okay, 9th MCQ. Let's see, I'll explain. I'll move this up. So 9th MCQ, Pramodi gave answer 3rd, Tamasha gave 3rd, and Ishara also gave the same answer 3rd. Good. All 3 of you gave the same answer. Answer is 3. They do not they don't form oxyanion. That is incorrect one. Very good. They do not form oxyanion. What are oxyanions? Example, you can write MnO4 minus oxyanion. Manganate. Chromate, Cr2, dichromate, Cr2O7 2 minus, dichromate. Manganate, permanganate. MnO4 2 minus, MnO4 minus. All these are oxyanions, CrO4 2 minus. These are the oxyanions formed by D block. They don't form oxyanion, incorrect. Not true. Others are, they show variable oxidation state. They have catalytic properties, correct. They form complexes, yes. Okay, so that one is easy now, no need to explain, right? Okay, all of you are correct. Question number 10, I'll erase the screen. Question number 10. D block that shows highest electrical conduction. Highest electrical conductivity. Again, what matters for the electrical conductivity? Availability of delocalized electrons from the valence shell. Valence shell, delocalized electrons helps in the conduction of electricity. Yes. Question number 10. You can post the answer in the chat. Yes, 10th MCQ. This is also like directly recalling the previous memory. Pramod gave fourth answer, Ijara first answer, Tamasa fourth. Okay, I'll check. Pramod gave manganese, and the other Tamasha and Ishara gave copper. Copper or manganese. Copper or manganese. So those are the two answers we have given. I'll explain why. What are the factors affecting the electrical conductivity of metals? Electrical conductivity of metals. This is 2011. Question number 1. First MCQ 2011 LL Web. First MCQ. So remember, ability of the valence electrons or the outermost electrons to get delocalized. Electrical conductivity and heat conduct, both thermal and electrical conductivity depends on the ability of valence electrons to get delocalized. And that also when there are unpaired valence electrons. Unpaired valence electrons have higher tendency. Unpaired valence electrons having higher tendency to get delocalized, therefore they conduct electricity better. Please write, can you please write it? Unpaired valence electrons. Unpaired electrons in the valence shell has higher tendency to get delocalized. This is a good question. They can repeat this again. What is the outermost shell here? Outermost shell is not D, 4s. Fourth ne? Unpaired. Okay, I'll write. Please write this statement, everyone. Unpaired electrons in the outermost shell. Unpaired electrons in the outermost shell have higher tendency. Outermost shell, that is also called valence shell, has you have higher tendency to get delocalized. Higher tendency to get delocalized, and they contribute to both thermal and electrical electrical and thermal conductivity. Both electrical and thermal conductivity. This is very important. What? Unpaired word important. Outermost shell important. Unpaired important. Outermost shell important. Tendency to get delocalized. Important. And that one, if there's higher tendency, that means ability to get delocalized also matters. Number of valence electrons also matters. Unpaired electrons. There are three conditions here: unpaired, outermost, and number of valence electrons. So some having less unpaired electrons in the outermost shell, then conductivity is less. Is that clear? Therefore, from metal to metal, electrical conductivity changes due to this. I'll give one example. Sodium, magnesium and aluminium. Which one conduct electricity? Which one has high electrical conductivity out of these three? Which one has out of these three, which one has high electrical conductivity? Aluminium can contribute 3 from the valence shell. Magnesium can contribute only 2 electrons. Sodium can contribute only 1 electron. Inner electrons are useless. Inner electrons cannot form bonds. Inner electrons cannot conduct electricity. Inner electrons cannot conduct heat. So therefore the most important shell of an atom or the element is the outermost shell, which predicts its behavior and the properties. Is that clear? Now everyone should be able to get the same answer. Highest electrical conductivity, check the outermost shell. Are there any unpaired electron in the outermost shell of manganese? Manganese, what is the atomic number? 25, ne? 3d5. There are so many unpaired electrons, but they are not in the outermost shell. Ne? That's the reason. Is that clear, everyone? 3d5 4s2 is there. Then you will argue, answer there are 5 electrons in the 5 unpaired electron. Yes, but not in the outermost shell. Ne? That is the problem. That's why you can't take manganese wrong here. Okay. Who gave manganese? Question number 10. Okay. Ishara gave the first answer. Ishara, is that clear now? 10th one. Manganese, there are unpaired electrons, but not in the outermost shell. Outermost shell is the fourth one. Okay, right. Then, okay, Ishara. Now we have changed the answer. Good. So the answer is fourth, copper. Copper outermost shell has what? 3d10, 4s1. There's one unpaired electron in the outermost shell of copper. Therefore, copper conducts electricity. And when the radius increases, so then you can argue sodium also has one electron. Then sodium or copper conduct electricity better. Like that you can convey, but I don't. In the exam they will not make this that complex. But when the electrons are held more closer to the nucleus, then also tendency to get delocalized less. That also will affect. No? Yeah. Anyway, that's metallic bonding matters. Strength of the metallic bonding also will affect. Okay, that's more. So the answer is copper, right? Not manganese. That is 2011 paper. I'll erase the screen. Then question number 11. 11th MCQ. Yes. 19. Can you quickly post the answer to the chat? Yes. Okay. Let's see. X3 plus with 5 unpaired electron. X3 plus underline 5 unpaired electrons underline in the aqueous solution. An atom of element X has 4 unpaired electrons in the ground state, 4 unpaired electrons in the ground state. 4 unpaired electrons in the ground state. 4 unpaired electrons in the ground state. That's what the answer. X3 plus. So first let's see X. Which one has 4 unpaired electrons in the ground state? X. And X3 plus. Yes. Answer is Ishara gave fourth, Pramudi gave second, Tamasha gave second. Okay. Fourth and second. The 19th MCQ. 2011, the same paper. Okay. If you take, okay, I'll check one by one. First, I'll explain the ones that are given here. You have given fourth and second. Fourth and second. Who gave second? Pramudi and Tamasha. Ishara gave fourth. Fourth and second means chromium and cobalt. Chromium and cobalt. Chromium and cobalt. Okay, so best thing is you write the configuration. Then you can get the answer easily. Write the configuration. But if you have some idea, then you can get it easily. About this, if you are familiar, that's why I told you should be familiar with the periodic table and the configuration. Then you can get the answer easily. Right. Okay. First, I will check which ions can form X3 plus. That's a hint. Now sync. Now remember, some of these cannot form 3 plus ion. Then you can easily omit. If there's anyone who cannot form X3 plus, you can omit it. That is one method, right? Okay, I'll write the list: scandium, titanium, vanadium, chromium, manganese, iron, cobalt. All these can form 3D. They can form 3 plus, 2 plus. All are possible. 3 plus, I'll give the list. X3 plus can be formed by these. I'll write that list first. Scandium can form X3 plus. Titanium can form 3 plus. Vanadium can form 3 plus. Chromium can form 3 plus ions. Then manganese can form 3 plus. Iron can form ferrous ferric 3 plus. And cobalt possible. Cobalt possible. So if you consider that, then that is from D block. Aluminium also can form 3 plus. Then that is not a filter here. So you can't filter from that. Then next one. So group 13 also can. Group 13, that means 13 group: boron, aluminium, gallium, indium, thallium. So they also can form 3 plus ion. Group 13 and 3D series, this one can form 3 plus ion. Then next one is ground state. 5 unpaired electron, X3 plus. And ground state, how many unpaired electron? Ion ground state, okay, I'll write one by one. Ground state of, because I'm going to write the configuration one by one each, you can check with the configuration. Ion ground state has how many electrons? 4 unpaired electrons. 4 unpaired electron. Ground state. Chromium ground state has 5 unpaired electrons. 3d5. 3d5. Scandium ground state has 1 unpaired electron. 3d 1 4s2, 3d 1 4s2. Here 3d 1 4s2. So unpaired electron 1. Unpaired word important. If you take chromium 3d5, 3d5 4s2. That's why here 5 unpaired electron. Okay. And also the same scenario, you can write 3d6 4s2. 3d6 4s2. Right. Then this is the ground state. Then if you take cobalt, how many unpaired electrons? 3 unpaired electrons. 3. Right. Aluminium has only 1 unpaired electron. 4s2 3v1. Right. Aluminium 13 3s2. Then ionic state. In ionic form, how many unpaired electron? Which one has maximum number of unpaired electrons? Answer will be Fe. Fe has ion. Fe3 plus has the highest unpaired electrons in the ionic state. Sorry, 4 unpaired electrons. How to write Fe3 plus? 3d 5. So this one here 3d 5 and 4s not. So this one has 5 unpaired electron. That's for ground state 4 and ionic state 5 here. It has 5 unpaired electron. Is that clear, everyone? If you only can check the configuration of all these. Answer is first one. 11th MCQ, the answer is first. None of you are correct in that one. You gave second. Chromium 5 unpaired electrons in the ionic state. ground state chromium has 5 unpaired electrons. Is that clear, everyone? Chromium ground 3d5OS2. Chromium ground state, there are 5 unpaired electrons. Actually, it's become the 4s1, no? There are 6 unpaired electron. 6 unpaired electron, not 5. Ground state. So then the I itself, if you take Cr3 plus 3d4, 3d4, 3d3, sorry, 3d3. Chromium 3d5OS1. When it becomes Cr3 plus, it becomes 3d3, no? Only 3 unpaired electron. And they have given there are 5 unpaired electrons. Is that clear, everyone? Why the Pramudya and Tamasha's second answer is wrong. 5 unpaired electrons in the X3 plus. That means Cr3 plus not having 5 unpaired electron. Cr has 6 unpaired electron. 3D 5OS1. Okay, Cr has 6 unpaired electron. But here they have given ground state only 4 unpaired electrons. 6 unpaired in ground state. Right? So this one has only 3 unpaired electron. Is that clear, everyone? Because this is just configuration. I think in Hari you have done it. Ishara, who gave Pramodi? Second answer is not possible. I gave the reason. And again, who gave the fourth answer? Ishara. Fourth answer. Cobalt. Can you take cobalt? Cobalt, what is the configuration? Cobalt atomic number 287, 3d7 4s2. Cobalt 3d7 4s2. So are there 4 unpaired electrons in 3d7? 3d7 4 unpaired electrons. 1, 2, 3, 4, 5, then 6, 7. Only 3 unpaired electrons. 3 unpaired electrons. Not 4, not 5, not 4. And if you, so this is how now configuration will be a bit familiar, right? Outermost configuration. No need to write the entire configuration. Outermost configuration you should handle. It takes time, I know, but you can get the answer. Nothing else. Only the configuration. The configuration. Nothing else. Because none of you are correct with this. Answer is iron, no? Fe. Right. Either I think configuration, you know. Now this one, like if you do a mistake in the LL paper, like kind of you are losing marks unnecessarily because you know the theory, right? Configuration, you know how to write iron as well as ground state. But the problem is you have not read the question properly. What I can now, this is what I can see from your answers. You know the configuration, you have learned it. It's the basic thing that you learn in general chemistry at the beginning of the syllabus. But the problem is you are not paying attention. 5 unpaired electrons, you normally you learn in the ground state. But here they have given in the ionic form. 3 plus ion. Cation. So therefore, remember in the LOL paper, not only the chemistry knowledge, there are questions to see whether you can follow the instructions given, whether you are paying attention to the active word of the question, whether you are paying attention to the question word, active word of the question, and whether you are following the instructions given, right? Whether you can understand what they are going to ask in less time. That also is skill. Okay. Now in Sri Lanka only this, but remember this paper and pencil work they evaluated only in Sri Lanka, but there are most of the other countries now this is outdated, right? Now once in a foreign university, one student has not written anything for the paper. but the lecturer has given 2 marks, so the maximum marks awarded 5 marks for that question. For the whole paper 5 marks. Now in Sri Lanka only 100 marks, so 5 marks, so they have awarded 5 marks but not written anything in the paper. But then they have question, why 2 marks? So he should be given 0 marks if he has not answered any questions at all. But then he has said, this student has come for the lectures on time, right? And he has to get up early. Lot of commitment for that, and he has good attendance, even though he has not answered the paper. For that also we have to, evaluate. Not only the paper and pencil work. There are students also leaving out from the school. Those who are not paying attention. Now I'll give one of the best example. There are educated people. They don't do anything on time. They have got a degree, but the rest of things nil, right? Because those things are not evaluated in the school or in the exam. Right? They have got 3 A's, 9 A's, or a degree and everything, but in the private sector, public sector, no, they are not doing the job well, or they are not coming to the work on time. These are the issues, because they don't L and local or O-level and A-level, they don't check these things. Somehow copying after copying also, if they get out of 40 or 50 MCQs, if they get like 36, 37, then automatically S pass is there, right? But the other countries, they don't evaluate, so they have to do a sport, community work. So they evaluate all this community work. That's also very important. Helping the others. Community work means helping the others. So you have to study as well as you have to preach the others, as well as you have to do some service to the community. Now the people become, this education system, they become so selfish because that is not the students or the teachers, that is the system, right? Therefore the other countries, this one they don't. Now in Sri Lanka also they are going to change the syllabus in 2023. 70% marks you have to earn from the school. Right? For the exam A not decided it, but up to grade 11 is decided. 30% for the final written paper and pencil work or the written exam, 30%, 17% you have to earn from the school before the exam. Why this 70%? From the assignment, assessment, practical work, and innovative problem solving ability and everything, all this they evaluate, and they will be not by the school teacher, those marks given by, there's a separate monitoring body, and election is held by deputy election, and like not by one person, something like that. There will be examiners in each zone and the province and the division. So then it's not biased, only problem is that, but then the students will go to the school, no? There will be less tuition in the future. That's good. Now what happens, he is fully exam oriented. Their religion and ethics and values, nothing is tested here. So we have prepared the students for a race. Now you also in that race and a target. They have a target and they are in the race. Somehow the other they are trying to reach that target. They don't consider about these values and helping each other, community service, nothing, right? Okay, so therefore we can't blame the students also, because this evaluation also they have to change. Then only the teaching method also will change, right? Then next one, there are students, like there are children those are not going to the school. And remember, most of the inventions in the world also not by those who have got degrees and formal education, informal education, no, not those who have not gone to a school. They have invented various stuff. There are so many examples I can give, right? Including the bulb, Thomas Alva Edison. So he has not got the formal education. New inventors in the world, they have not got a formal education, right? Anyway, so therefore one day at least your children, or if you become a lecturer, teacher, like whoever, that's very important, not to directly give the product, to get the answers from, actually answers with them, they have the knowledge. Some countries they start giving marks 100 and then they deduct. And now here we start the marks from 0. There are countries in the world, those who start the marks from 100 and then they reduce that. Okay, this mistake reduce this much, this mistake reduce this much, like that. But here in our country, we have to start from 0 to 100. There are different methods of evaluation. Right? And the other problem, no other country in the world is using A-level results for the university entrance, the selection. University selection, in our country only they use the A-level results. But the other countries, A-level everyone pass. A-level exam results not used for the university entrance. For the university entrance, there will be a separate entrance exam. Separate low entrance, like that. Low entrance exam. Niti Pravesha, like that, there are separate exam. So those who have passed the A-level, they can go for the low entrance exam. Is that clear? So if you are going, you can do a foreign degree, but before you enter, you have to register Sri Lankan Medical Council, Sri Lankan Medical Council or whatever, to work as a doctor. In Sri Lanka, you have to do a separate exam held by the Medical Council. And if you fail that, even if you got a good degree from a UGC approved university, you are not allowed to work as a doctor in Sri Lanka. Something like that. You have to pass that. Or else, something like, kind of very, it's unfair actually, using A-level results by the UGC to select the students of the university. That's why it's become A-level, become local, become very, very competitive in our country. Okay. There are people those who are getting 3 years, but the other countries, what they can pass the A-level with 3 years, and then you can do the basic degree, and then you can for the medicine. You might not believe this. Some countries, they need a basic degree to do medicine. Then after that they can select medicine. They have to get the basic degree. Basic degree, sometimes non-science related subject also there. Okay, so like there are different systems in the other country, but anyway in Sri Lanka, kind of this is fully exam oriented one. Then question number 12. 11th I gave the answer, right? And 12th MCQ, which of the following statement is not true regarding chromate and dichromate ions? This is given in the D block short note at the beginning. Chromate and dichromate, not true again, not true, incorrect statement. Yes, who can give me quickly the answer? 2005 question number 14. Hurry up. Yes. Both contain highest chromium. What is the highest oxidation state of chromium? +6, right? Chromium, what is the highest oxidation state? +6, CrO3, CrO4 2 minus, CrO4 27, Cr2O7 2 minus. Okay, I'll check with the answers now. Twelfth MCQ. Tamasha gave fourth, Romati gave fourth, Ishara gave second. Fourth, second. Fourth, second. Fourth and second I'll mark here. Some of you gave the fourth answer and some of you gave the second answer. They are asking incorrect one. Not the correct statement, incorrect statement. Okay. A is first one is correct, and that's like common sense. +6 both, +6 in both. That's correct. Then both oxidize I minus to I2. Oxidation. If I minus get oxidized to I2, then CrO4 2 minus should become Cr3 plus. Cr2O7 2 minus also should become Cr3 plus. Right? Now I minus is easy to oxidize. Sometimes you can use even H2O2. H2O2 even can be used to oxidize I minus, because but you can't oxidize Cl minus, F minus using this, but I minus is easy to oxidize. No need strong oxidizing agent. Chromate, dichromate, oxidizing agent. Can remember in organic chemistry also we use potassium permanganate, potassium dichromate, potassium chromate as oxidizing agent. Therefore, both oxidize I minus to I2. Can. It's possible, right? Who gave this answer second? Pramodi gave second. Sorry, Ishara gave second. Sorry. Yeah. Ishara, he is correct, no? Right. Then third. I'll put right click here. He is correct. A is true. B also true. Then what about third one? Sorry, second. They are equilibrium with each other in the aqueous solution. Okay, what does that mean? Look at the screen here. Chromate and dichromate. Look at the screen, everyone. This one can be used. It's a very good one. This link with physical chemistry again. I'll explain. CR. I have given this in the D block short note at the beginning. Chromate can be converted to dichromate depending on the pH value or the acidity and the basicity of the medium. Look at the screen. Chromate yellow, complex yellow colored one, oxygen ion, and it's become dichromate Cr2O7 2 minus. No change in the oxidation number. Here also oxidation number plus 3. In chromate also plus 3, dichromate also plus 3. Sorry, plus 6. This also plus 6. This also plus 6. Is that clear? Now, dichromate is orange. Chromate is yellow, dichromate is orange. Now, how to oxygen balancing in the acidic medium? Oxygen balancing, which side oxygen is against? So here I have put 2 here because there are 2 chromium. In this side 8 oxygen, this side 7 oxygen. Then you have to put H2O this side. So this side you have to put H2H plus for balancing hydrogen. Is that clear? First oxygen balancing done by adding H2O to the right hand side. 8 oxygen left side. To make for oxygen balancing you have to put water. Always to the side where oxygen is lacking. Now you can see here, if you put acid H plus, when you are putting acid, what is the color? You get the orange color, because when you put acid, forward reaction is speed up, forward reaction goes. But if you are putting water, or if you neutralize this, or if you are putting base, the reaction goes towards the yellow. Basic medium is yellow. Same sample, I mean the same thing. This what happened in the basic medium? Basic medium, what is the color? Yellow color. In the acidic medium, what is the color? In the acidic medium, it turns orange. In the basic medium, it turns yellow. So what is the color of the, that is chromate ion color in the basic medium? Is that clear, everyone? Basic medium is no H plus. When H plus is added, to reduce that H plus, forward reaction speed up. That means more and more dichromate is forming. More and more dichromate is forming. So I put the red here. That is the acidic color, red. So if you take the neutralizer less, as when the acidity decreases, it turns yellow. Basic. I have given that at the beginning of the D block short note book. I don't know how many of you refer that. If you want to show it now, D block short notes here at the beginning I have given this. Can you see here? Oxygen ion here. Page number 1, oxygen ion, manganate. Here equilibrium between CrO4 2 minus and Cr2O7. Can you see here? Please write near this question. Please refer D block short note page 1. D block short note page 1. Done? Shall I erase this? Right. Now, okay. So you can see here. A and 1 and 2 correct. See, they are equilibrium with each other in aqueous solution. That's also correct, no? That's also correct. First one correct, 2 correct, 3 also correct. Fourth one. Both gives precipitate with ammonium hydroxide. Both gives precipitate with ammonium hydroxide. That is wrong. That is wrong. Chromate and dichromate won't precipitate. It won't form precipitate with OH minus. If you put OH minus, this become chromate ion. Chromate ion. If you put acid, it become dichromate. Fourth one is the incorrect one. Who gave the fourth answer? Tamasha and Pramod gave fourth answer. Ishara, second answer. Ishara, did you understand now? Fourth one is wrong, no? That is chromic ion, not chromate and dichromate. Okay. Cr3 plus, but not CrO42 minus. So the incorrect one will be fourth. Then fifth one, both reduced by Cr3 plus by SO2. Yeah, that's correct. Okay, look at the screen here. These redox reactions, they can ask you on balancing in the exam. They can ask you on balancing in the exam. Let me, so this both are reduced by reduced to Cr3 plus by SO2. If you take dichromate and if you pass sulfur dioxide gas, dichromate become Cr3 plus. So it's get reduced. And what will happen to sulfur dioxide? SO2 get oxidized. SO2 get oxidized and Cr2O7 get reduced. So SO2 get oxidized to SO4 2 minus. Same scenario, dichromate also get reduced to Cr2O7 get reduced to. You should know how to combine this and balance the equation. Redox balancing, oxidation reduction reactions. Cr2O7 become, CrO4 2 minus. Sorry, CrO4 2 minus also get reduced to Cr3 plus in the acidic medium. This happens in the acidic medium. Okay, CrO4 2 minus becomes Cr3 plus, and SO2 become. SO2 will become SO4 2 minus. SO4 2 minus. So both get reduced by SO2. Correct. Correct. Then answer is fourth. Okay, answer is fourth. Both gives precipitate. That is wrong. Question number 30. 13th MCQ. Which one of the following statement is not true? Again, the incorrect one they ask. Not true, I'll highlight. With regard to 3D block elements of the periodic table, 3D, 3 block, the 3D elements of the D block. Okay, can you quickly post the answer to chat? Question number 13. Pramudi gave the answer and Ishara gave the answer. Pramudi gave first, Ishara gave third. 1 and 3. This is again 2011. 2011 question number 9. Question number 9. I think the best method to get the answer easily here to omit the most incorrect one. Okay, let's see one by one. First statement. First statement is correct. First statement is correct, no? They have given scandium dinachromium manganese. Highest oxidation state is equal to the group they belongs. Highest oxidation state is equal to the group. Yes, correct. That's correct. That's correct. Example. What is the highest oxidation state? Is scandium. If you look at the long form of the periodic table, it's there. 3b. Scandium means atomic number 21, 3b. So the plus 3. Right? 4b. Titanium plus 4. Vanadium 5b. Like that. And manganese plus 7. 7b. Okay. So you can look at the long form of the periodic table contained in A and B. Yeah. That's correct. About these elements. Second one. Second statement. Highest oxidation state of each of these elements less than the number of group. Highest oxidation state. If you want, I'll write the highest oxidation state, right? Scandium plus 3. Titanium plus 4. Vanadium plus 5. And chromium plus 6. Manganese plus 7. Titanium plus 1. Scandium plus 3, right? That's correct. For the group. But on a new syllabus, actually, this will not happen, because in the new syllabus you don't get the A series and B series, so you get like just 1 to 18. You don't use the Roman numbers. Group 18, like that. Highest oxidation state of each element less than the number of the group to which element belongs. Yes, let's see second statement. Second statement also correct, no? That's matched. I'll comment on your answers again now. Who gave the 13th second answer? 13th 1 and 3. Pramodi and Tamasha gave the first answer. First answer is correct, right? Tamasha and Pramodi. You want me to show the periodic table? Scandium that 3b. Actually, all of the periodic table 1 to 8, that A series 1A, 2A, 3A. But after that you get scandium, the D block you start with 3b, no? 3b. Scandium 3b. Scandium titanium 4b, like that, can you remember? Because then it's match. There's the incorrect one. Third one. All cations of the element have vacant 4s orbital and all the valence electrons occupy D. What about third statement? Cation plus all the cations, all be important, of the elements have vacant 4s orbital and all the valence electrons occupy in D orbital. All the cation means what? When you get the cation, not the ground, be careful, not the ground state. If you take plus 2 oxidation state and above, 4s2 is empty. Plus 2 means what? 4s is empty. 4s is empty. Because 4s is outermost shell. When a cation is formed, electrons are first given out from the outermost shell. Then what happen? 3D is left. Valence electron is occupied in the 3D in those cations. So therefore third also correct. What about fourth? They are asking the incorrect statement, no? Ions such as manganese dichromate, chromate, which elements in their highest oxidation state tend to be good reducing agent, whereas ions such as nickel and zinc are good oxidizing agent. Actually, what is the strongest oxidizing agent in your syllabus? Oxidizing agent undergo reduction. Oxidizing agent undergo reduction. In your syllabus, most strongest oxidizing agent will be acidified KMnO4. MnO4 minus highest oxidation state +7. Then it can never undergo oxidation again, because now already it is in its highest oxidation state +7. So they act as good what agent, not reducing. What, because of this word is wrong. They act as good stable and tend to be good not reducing agent. They become what agent? Oxidizing agent. Reducing agent undergo oxidation. They undergo oxidation again? Can't. They can undergo only reduction. If they can undergo reduction, the other person get oxidized. That's how we call it oxidizing agent. The agent which makes the other person oxidize. MnO4 minus can never undergo oxidation again. MnO4 minus in its highest oxidation state. Therefore, it can undergo only reduction to Mn2 plus. So then it become what? This one undergo reduction. Then the other guy undergo oxidation. Example SO2. SO2 get oxidized to SO4. So then this MnO4 minus act as what agent? Oxidizing agent, not reducing agent. Very important. It acts as what agent? MnO4 minus become Mn2 plus by undergoing reduction, and the other person get oxidized. Therefore MnO4 minus act as oxidizing agent, right? That is one of the most strongest oxidizing agent available in your syllabus, MnO4 minus. So therefore the fourth statement is wrong. Is that clear, everyone? Any questions? Because of reducing agent it's wrong. It is, they are oxidizing agent. Even chromium, chromate and dichromate, chromium in its highest oxidation state. Chromium and manganese in dichromate, in chromate, they can never undergo oxidation again because they are already in their highest oxidation state. Right, then next one. So last one, zinc has the lowest melting point. We discussed this, right? Today we discussed zinc has the lowest melting point. See, that question again they have asked in 2011. I think 2000 or 2001 paper we discussed. So they have given one of that here. That's true. Is that clear, everyone? Do you want me to explain any part? So the answer is fourth. Who has got the correct answer for the 13th MCQ? Fourth answer, none of you. 13 answer is fourth. Incorrect one is fourth. Not true is fourth. Okay, is that clear, everyone? MnO4 minus what agent? Oxidizing agent, not the reducing agent. Because, right. Clear, everyone? Question number 13. Any doubt? If you want me to explain again, tell me, because none of you have got the correct answer for this. Then question number 14. Can you quickly post the answer to 14th MCQ? Yes, 14. 2011 again, question number 30. 30th MCQ. Actually, this one kind of recalling the previous memory. It's not a good MCQ because we have to memorize the colors here, right? It's kind of my advice, this D block, some other parts again, like especially inorganic chemistry, when the exam is close, again you have to quickly go through because colors and all you will forget easily, no? If you are not frequent doing questions from there. Yellow, blue, light. Okay, let's see. Yellow, blue, light purple. Yellow, blue and light purple respectively. Let's see. This is vanadium, no? Have I given this in your short notebook? If not, please add that here if possible. Vanadium, the color. So VO2 plus yellow. Okay, VO2 plus yellow. VO2 plus yellow. Then what is blue? VO2 plus means, like, look at the screen, everyone. Like VO2 plus means you can get confused if you don't look at the screen. VO2 is subscript here, right? VO2 plus. Then again, blue one will be VO2 plus. Look at the screen, I am writing on the screen. VO2 plus. The light purple will be what? Purple. V2 plus. V2 plus will be light purple. That's how you get the answer easily. Understood? This one, of course, I don't think they'll ask on the new syllabus this type of questions, because it's like just recalling the previous memory. So what is the answer then? What is the answer? Question number 14. Have you all learned this? Answer is 3, huh? Answer is 3. Have you all learned in the theory class the colors of this? Answer is 3. And you get this order in the third one. There's a small correction here in the third answer, right? Because it should be like 2 should come here. There's a small correction here. Otherwise both are same. It should be VO2 plus here, right? Like that. VO2 plus. Like this. Then question number 15. How to distinguish ferrous and ferric? Yes, quickly post the answer to chat. 15th MCQ. Fe2 plus and Fe3 plus. Correct statement they ask, huh? Most of the previous and the incorrect one they ask. Correct one. Hurry up. Okay, Ishara gave the answer. What were the others? Tamasha also gave the same answer. Pramodi? 15th. This is 1994. 1994 56 MCQ. 1994 56 MCQ. Yes? Aqueous ammonia cannot be used. Aqueous NaOH cannot be used. Bromine water cannot be used. Aqueous can be used. Should be Br2, no? Br2 CCl4. Actually, aqueous ammonia, sodium hydroxide can, right? Because ferrous hydroxide and ferric hydroxide color is different. Ammonia also same thing. reactors. Pramodi gave second, Ishara and Tamasha gave fourth or second. Answer is fourth, right? Answer is fourth. Can be used because of cannot is wrong. Bromine because if look at the screen, Pramodi, ferrous can get oxidized to ferric. Then bromine water, CCl for bromine can get reduced to Br minus. So this is oxidation and this is reduction. But ferric ion cannot get oxidized further. Ferric ion cannot get oxidized further. Okay. Ferrous ion can get oxidized further, not ferric. So the answer is fourth. Very good. It should be Br2. Huh? Then question number 16. 16, there's a lot to read. Yeah, I have done 16. This is 1996. Have I done this? I think that this paper in IUPAC part we have done, no? Yeah, and this question number 28, 29, 31, 32, all this we have done, 33, 34. Almost everything we have done except the last few MCQs, 37 onwards. So here we have to do 36 onwards, and before that, okay, before 1990s I'll discuss separately this one because some of them are not relevant to the syllabus now. Therefore, yeah, 1994 to 1999 I'll discuss next week because I have to check again one by one because some of these not relevant to the syllabus now. Okay, so because a D block introduced to the syllabus in 1997, especially 1997, 1994, 1996 the problem. Right. We'll discuss this one. 19th MCQ. Others I'll discuss next day. This 1990s papers I'll discuss next day. Yeah? I will discuss today 2000 to onwards. 19th MCQ, can you quickly? But the 1990s, some of the questions not relevant to the syllabus. That's why. 19th, who can? Ishara gave the answer. Pramodi gave the answer. Tamasha, 19th MCQ. Answer is 1 and 5. Pramodi 1, Tamasha 1, Ishara 5. One and 5. Okay, can I have the coordinating number? I mean, coordination number. CO 3 plus maximum like the ligands that can be combined will be 6. So you can see here. Please write here. Cobalt can combine with maximum 6 ligands. That is the scenario here. You should know. Please write everyone. Cobalt can combine with maximum 3 ligands. CO3 plus can combine maximum with 6 ligands. CO3 plus can combine with maximum 6 ligands. 6 ligands. Then you can easily get the answer. So there are two answers you can directly omit. Third and fourth you can directly omit. Why? There are 7 ligands here. Here there are 7 ligands, 7. Therefore this is wrong. And here you have again more than 6 ligands in the fourth one. Right? 3 and 4 we can directly omit because there are more than 6 ligands. Then from the remaining ones, first one there are 6 ligands, second also 6 ligands, fifth also number of ligands. Okay. Now you have to check whether it's matched with the charge. So actually the answer is here first one. When you check the charge also, whether you have to get whether you are getting 3 plus or not. 3 plus or not. So look at the screen. How come this first? Ammonia is neutral ligand. NH3 5 neutral ligand. Therefore, to get here Cl2, this should be what charge? 2 plus. This should be 2 plus. Then you get Cl2 here. To get 2 plus and cobalt should be plus 3. How many Cl should be required? Cobalt plus 3. To get net charge of the cationic complex 2 plus, there must be only one chlorine. Look at the screen, everyone. To get 2 plus charge, there can be only one chlorine. Then plus 3 and minus 1, you get plus 3 and minus 1, you get 2 plus or plus 2. Is that clear? To cancel 2 plus, the most important thing here, simple anion is Cl2, here Cl2. That is the most important thing. This Cl2, to get Cl2 here, this should be 2 plus. To get 2 plus, there must be only one chlorine inside the square bracket, because ammonia is a neutral ligand. So the answer is first one. Let's see how many of you got this answer. First answer, Tamasha, first one. Probably first one. Ishara, is that clear? The fifth answer is wrong. Fifth one, you don't get, no. Fifth one, what is the charge here? Here minus 1. Then here only one chlorine added. No, one chlorine added means what? Overall charge plus. To get the plus, this should be what? Plus 2, no? But actually in the question they have got CO3 plus. In the fifth answer, cobalt get plus 2 charge. The oxidation, right? Charge will be plus 2, or the oxidation will be plus 2. Is that clear? Shara? Right. Okay. Pramodi and Tamasha, correct. Right. I'll erase the screen now. Then 20th MCQ. Can you quickly post the answer to chat? Which of the following groups, the compounds, ions, or do all the members of the group have the nearly the same color? Nearly the same color. The colors also you have to memorize, no? 2002. Can you quickly post the answer to chat? Same color. Most of these sulfides are black, okay? Done? Okay. Look at the screen. I'll give the set of the colors. Out of this, look at the screen, everyone. You get yellow color ones. Okay. Yellow colored ones. I'll write the list. Yellow. What are yellow one? Cadmium sulfide is yellow. Please write the list. Cadmium sulfide yellow. Silver iodide yellow, AgI. Then potassium chromate yellow. Not dichromate, potassium chromate yellow. Then I will write blue ones. Blue ones will be like, I will write the list here. What are the blue ones? nickel complex, nickel hexamine, that one is blue. 2 plus. What else blue? CuCl2 and CoCl4, 2 minus. Then what are black ones? There are 2 black precipitate, copper sulfide and nickel sulfide, NiS, they are black. Then pink one will be manganese chloride. Then white one will be zinc sulfide white, and green will be nickel chloride. Green will be nickel chloride, NiCl2, green. So what is the answer? Now everyone should be able to get the correct answer. Yes, what is the answer now? The answer is 5, no? Answer will be 5. D. Sorry, not D. Sir, wait 1 second. Cadmium sulfide. A is correct. A is correct. Then nickel hexamine, cobalt is blue, and copper. Yeah, marking they have given the first answer. That means A and B they have taken as correct. Copper zinc sulfide, that is you can't take this one. This also you can't take, because manganese chloride is pink. Manganese chloride pink. Right. Okay. Then next one. Answer is A and B. Zinc sulfide is white. Zinc sulfide is white, not black. That's why you can't take C. Is that clear? So then, shall we discuss the rest next day? Only these few, and please copy. I will be discussing essay type questions, because IUPAC ones no need to do. Only last 3 essay type MCQs here. Last 3 MCQs, 39, 40, and 37, 30 area. Last 4 MCQs, and then here 22, 21, 22, 23. 24, 25, 26. Yeah. And I will be discussing essay type questions also here. D block essays, fast essays. Right. Please complete this one. Today I posted this to your WhatsApp. Okay, then we'll stop for today, and we'll continue the rest next day. Okay, then good night and God bless you.
Thank you, sir.
Yes, sir. Good night.